I think I need the permission to share my screen.
Yeah, once.
It shows that host disabled.
Is it okay now?
Yeah.
So I wanted to welcome Sanju here to speak about, the difference between AI, ML, data science, and data analytics, because a lot of children have this sort of confusion that how are they all related? What are the career paths they should take in order to decide which one to take? So I'd like to now hand it over to Sanju. She's currently pursuing her PhD in the University of Alberta from Canada. And Sanju, you can introduce yourself and then take it forward from here.
Yeah, I can do that. Just give me a second. I just want to. Just give me a second. I just want to take my notes as well. So is my screen like, can you see my screen completely?
Yeah.
Yes, yeah. It's fine now, right? Yeah. So I just think it's yes. Yeah, so basically, for today's session, I will be trying to like make it a bit more clear what's the difference between AI, machine learning, data science, and data analytics. And then towards the end, I'll just show some career, like if you're choosing data analytics, like what jobs do you get? For data science, what jobs do you get? And what is the difference between them? And how do you understand that what's your real interest so that you can choose the appropriate one? So before I start that, to say a few lines about me. So basically, I'm currently doing my PhD at University of Alberta. So it's a university in Canada, and it's situated in the province called as Alberta. So in the right bottom image, you can see is one of my the program that I attended. It was my Google Developer Group event. And so basically we had talks. It was a part of International Women Day, so we had talks from different pioneers that were women, and they were explaining their research in different fields. And also, I just quickly wanted to say a bit about where I stay. Like, it's in Alberta, so I just wanted to like quickly just go through a very short video, maybe a 2-minute video, to show how beautiful like the Jasper and Banff is in Alberta. So for those who don't know, so I just quickly go through it. It's just a short video. So it has beautiful, like there are lots of beautiful hills, mountains, and the landscape is really beautiful. And so if ever like for sure, like your future, when you get to travel and you're able to see this beautiful place, I would encourage. So I'll just quickly show through it.
How cool is this museum? It looks like a fort. Hello. I am currently on my way to Jasper National Park here in Canada.
Yeah, so this is a very short video and it's a very beautiful place. Yeah, so now let's go on to the next slides. 1 second, just give me a second. Yeah. Yeah. You can see my slides, right? Okay. Yeah, so now let's get into trying to understand the difference between AI, machine learning, and deep learning first. So AI is a broader view of everything. So AI for artificial intelligence, basically, it's any techniques that enables computers to mimic human intelligence by using different algorithms or models like decision tree and deep learning network. And machine learning, it's a subset of AI. So in machine learning, basically, you try to understand first the patterns in the data and make predictions. For that, we use different algorithms called as linear regression and like decision tree, random forest, etc. And then you can see what is deep learning. Deep learning is a subset of machine learning. In deep learning, how is deep learning different to machine learning? In deep learning, basically, we tackle with large amount of data. And also like in machine learning, the data might be a bit less so that we can run it on normal machines. Like on a computer, you can easily run machine learning models. But if you need deep learning, if you want to deploy deep learning models, for example, like using neural network architectures, for that, you have to basically use high intensive GPUs for processing. We cannot use a simple computer for running your deep learning programs. So that's the difference. And also deep learning requires a large number of data. If you want to like model such algorithms, the amount of data you need is also intense. Next, let's understand a bit more. That is, now we know that AI is a broader view of everything that you have, and machine learning is the subset of AI, that is artificial intelligence, and deep learning is a subset of machine learning. So now next we need to understand of what's the difference between data science and data analytics. So in data science, as you can see in the circle shown, so data science basically combines elements of statistics, computer science, and some few domain expertise to extract the different insights from the data. And in data science, we do different processes like data cleaning. If you want to clean the data, for example, your data may contain like noisy data, or it can contain some missing values. So for that, you may have to do some data cleaning, preparation for analysis of your data, and certain modeling. And also you may have to interpret the data. So basically data science combines your computer science and statistics together. Whereas when you see data analytics, the other circle, smaller circle, so it's a narrower field than data science. And basically, data analytics basically focuses to identify patterns and trends in your data so that you can inform like business decisions. So, for example, you're doing some programming and you want to share it to people who are of non-technical backgrounds. That is, if you want to share your graphs or whatever graphs you plot or whatever analysis you do in your data, and you want to inform it to non-technical team, that is, who does not have any technical knowledge. How do you show it to them? That is, once you all get to be an expert in doing some programming language and you want to converse it with people of business background who does not know anything about programming. So you'll have to show some sort of graphs like plots and explain it to them. So data analytics will include more of that, trying to understand like few insights from the data and show it to the outer world, especially to those who like those people who are of non-technical background, that is, who does not know about any programming, so that they can make some decisions for some sort of business that they are trying to work on. So basically, data analytics is about visualizing, summarizing your data, and it will require a bit less of programming background when you want to go for data analytics. But the career paths we can maybe discuss in the next slides. So right now we just need to know that artificial intelligence is the broader most, and machine learning is a part of subset of AI, and deep learning is a part of machine learning, is a subset of machine learning. So deep learning and machine learning are very correlated when you see it in practical scenario. And then in data science, you will have statistics. By statistics, I mean, for example, you have a data and you want to find out mean, variance. So this is a different statistical approach. And also you have this chi-square mean test. So there we try to understand how similar is your input and your predicted data. So instead of using different machine learning models in data science, you use more of mathematical or statistical approach for analyzing your data. And for having visualization purposes or trying to summarize the data, you use data analytics. That's where data analytics fall in. So this is a major difference. So data analytics would require less programming background, and data science would require a bit of programming background, obviously, and also a good understanding of statistical approaches that are used in for different prediction or analysis of the data. And then machine learning and deep learning, or whatever falls under AI, they will require good background of programming and good understanding of different logic, so that you can apply it to your problem to solve different issues like image classification or any other many machine learning problems that you have right now. So these we can go in the next slides, we can see that. So to give a quick overview of what is deep learning model, currently most of the researchers work in deep learning models because deep learning models like even though they take a large amount of data, we can do a lot of predictions and better analysis of the data. So deep learning is usually done, and so let's see a basic example of a deep learning model. So assuming that you want to identify whether the input that you give to your model is a dog or a cat, for example. So first, what you do is that you have a data set. The data set may contain information about dog. That is, if you have X number of features, like if your eyes look like this or if your nose looks in this specification, then it's a dog. And for cat, if you check cat's features, like for example, cat may have like these specifications of eyes, the ears, the mouth, then it falls under the cat in the for the category of a cat. So so initially in any model, whether it's machine learning or deep learning model, first you have to train your model. That is, you have a data set with all features for a dog and for a cat, for example, and you train your model. So these features come in, then it's a dog. If these features of a cat come in, then it's a cat. You have to classify it as a cat. So once you have done the training, what you do is for the testing part of your model, for example, if you're giving your dog the features of a dog as an input to your deep learning model, it will pass through different layers in a model, and each layer will do a specific task, a specific functionality, and then the output will be trying to predict what the input was. So as you see in this image right now, it's a dog. So you're giving the features of a dog to the deep learning network, and it has to predict whether it's a dog or not. So if our model was accurate, then it would predict as a dog. But if there are some issues in the model and whatever algorithm you're working is not as per the dimensions of the network, it may predict a cat. So it may have different predictions, but a basic deep learning model is basically used to predict the correct information based on how you have trained it. So that is important. So just giving a very high level idea about this. So basically in deep learning or machine learning models, basically you can predict this after learning from the data. It can predict when you give a new data to the model, it can predict whether it's, for example, in this case, whether it's a cat or a dog or any other animal. So this is an example of image classification. For example, you have different images of dogs and cats. You're training a model, and then when a new image comes in, so if I give an image of, for example, a giraffe, then the model should be able to tell me that it's a giraffe and it's not a dog or a cat. So how well the model does it depends on how well the model is trained and how well you have your other parameters well defined. This is a basic example of deep learning model. So let's see what are the applications of deep learning, where can you use it, and how can you use deep learning model in real-time scenarios. So first, it can be used in computer vision. So what does that mean? It can be used for image classification, like how you saw right now, whether if we give a set of images, can it classify whether it's a cat or a dog or any other animal or any other birds or anything like that. It can be used for detecting objects. It can be used for recognizing handwritten digits. For example, if different people write in a different way, then we can record those details and use it in the training phase. And during the testing phase, if I give a new handwriting, my model should be able to identify whose handwriting it is. So basically, different sort of image classification, object detection, etc., can be done by using these deep learning models. And next application of deep learning is in natural language processing. And so basically, that's what we are seeing right now, like building chatbots or translation services. So all these are with the help of using different deep learning techniques. And for emotion analysis or like you would have seen the translation service in Google, like if you want to translate your language, for example, if I type English and I wanted to translate to Hindi or any other languages, so we can use the natural language processing technique for that. Then other applications of deep learning include in robotics, that is basically used in robotics, basically to recognize and interact with the environment. That is, for example, if you want to train robots to recognize certain objects or navigate the way you want, or learn from the human, the interactions, we can use different deep learning models. So currently you can see that robots are used for different applications. Like we have small robots for cleaning the house. So they are able to understand which, like once the user specify these areas has to be cleaned in a house, the robots are able to do it. And also we have restaurants, even here in Canada, a few restaurants, the robots are able to serve the different customers or different people that come in a restaurant with the food that they want. Or so they've been used for multiple tasks these days. So next application of this deep learning could be in healthcare, basically to analyze medical images. And like you can see an example like cancer detection, like to detect whether it's a cancer or not based on the images that it receives. So your data is now your medical images, and then you pass this data to your deep learning model and make a prediction whether the image that you have passed shows any chances for cancer. So this is one use case where you can use these machine learning or deep learning models. Next application of deep learning models is for using in personal assistants like Alexa or Google Assistants. That is, that can recognize your voice. So if you might have noticed in your phone, you may have the Siri or also we have smart televisions these days where it takes the input your voice, and based on what you say, it tries to give you what you want to see. If you want to play some machine learning videos, you just say to your remote or to your smartphone that I want to play a machine learning video on and on what data or whatever you web page that you want. So these are a few examples of deep learning models, and that most researchers are working on in different ways. So right now, I know many of them who are working on healthcare and computer vision, and also NLP, because the chatbots, the different versions been coming up these days, and there are many people who are working on it. So what are the advantages of using these deep learning models? So first one would be to understand, we can understand the different patterns of the data. For example, as I said, cancer detection. So once we have the data, it can be in the form of images or time series data. We are able to understand the trends and patterns so that it can be used for different applications like classification of cancer or trying to find different trends in them. And also and a good example is Amazon. When you purchase items online in Amazon or any other Flipkart or any other sites, they try to learn a pattern and then give you recommendations like, okay, you have bought these items earlier, so then these they might display new items that you may like, and they would say that, okay, you can go for these items as well. It may be of your interest. So that is a good thing. And then another advantage is of no human intervention is needed. That is, once you use these deep learning models, everything can be automated. Instead of making humans do certain tasks, you can tell the machine to do it automatically for you. So in short, it helps human life. And then we have continuous improvement. That's one of the advantage of using this. That is, for example, when you want to do a weather forecast, so it takes a lot of data to help you in forecasting the weather. If I want to know the weather for tomorrow, it uses the data or the previous data to help you in forecasting. Similarly, you can also forecast your weather, like if you want to know your weather, like what would be the weather after 2 weeks. So these are things that these are how these algorithms, like deep learning algorithms, play. They learn from your previous data and help you to predict up to a certain time. They can accurately predict. Sometimes they could be false. That's when we see the disadvantages side. And then other advantages would be like how we saw, like it can be used for a wide range of applications. It can handle multiple data. There's multiple variety or multidimensional data. And then, so what are the disadvantages? Right now, we have been seeing only the advantages, how it's helping to simplify human life, and how it can help for other scenarios. But let's see what's the disadvantages. Now, the main disadvantage is that data acquisition. That is, once we have data, there's lots of data. How do we handle data? How do we work on it? So that's important. That's one of the advantage and disadvantage, because if you don't know how to work well on a data, you might not get the correct results even. And then time and resources is one of the disadvantages. Some like machine learning or deep learning algorithm takes a lot amount of time and resources. That is, you cannot simply run on your computer. You may have to use servers which are highly sophisticated, and it would take a lot of days to run your model. You cannot get a result within one day. It may take about 2 to 3 days to run a model in order to do some sort of classification. So it's time consuming. And then the other disadvantages or challenges that we could have is interpretation of the results. So sometimes it is difficult to interpret the results generated by these algorithms. They might not be that clear than how you think. So initially, when you start doing simple models, it is very easy. If you want to classify a dog or a cat, it's quite easy. But once the problem that you have is very challenging, and also the data you have is enormous, it is not easy to understand the result very quickly. You might have to use more algorithms and more sophisticated tools in getting to know whether your result is as per how you expected or not. And then we have high error susceptibility is also a challenge. So once you get your data, that is the data, as I said in previous example, like images of your cat or dog or any other animal, for example, it may contain a lot of noisy data. A lot of noise can enter inside the data, or there can be lots of missing data in your data set. So in that case, when you have lots of missing data, sometimes the prediction, if you're trying to predict it's a cat, it may not be correct. It might be because of the missing data that you wrongly predicted it. So before you even deploy a machine learning model, is important. First step, you take your data, analyze it, check if there's some missing or noisy data. And only once you have made sure that your data is perfect for like deploying it, or perfect for you to apply some algorithms, you can use it even. So directly using some data will never or mostly won't give you the correct results. It may give you a wrong interpretation. Instead of telling it as a dog, it may give you a wrong prediction that it's a cat. So always first get the data and then do the data cleaning approaches of removing the noisy and missing data before you even deploy them or work on different algorithms. So I just quickly want to just go through the future of deep learning, or what currently the researchers or different people are working around. So first one is continuous advancement in model architecture. That is, once you have your machine learning model, it's very important to make it more efficient. Like right now, if you just simply create a machine learning model, which is very complex and so big, it's of no use. Why is it of no use? Because finally, when you create a model, it has to be a little compact and efficient, so that you can deploy them in your smartphones or smartwatches. So finally, once you have your model ready, your machine learning model ready, you want to deploy them and see how efficient it is when you deploy them in a smartphone. So if you want to deploy a model in a smartphone, it should be very efficient. You cannot simply just generate a very complex model and then deploy it. But as a first step, obviously, when you're working with it, your main intention is just to create a model. But later on, once you've reached a stage that you know very well about machine learning and deep learning, the next steps would be how to make it more efficient, more concise, and not just a very complex architecture. And then the next one is how you can apply in different domains. As you saw examples, we can apply it to robotics field, you can apply it to healthcare, you can apply it to different like natural language processing techniques like chatbots. So the area that you can apply it is very huge. So nowadays, most industries wants AI models or machine learning models deployed, like even including banks and everything. So in each industry, the future is quite good in using these models and helping them with some sort of predictions, or predicting how their stock market would go, or predicting in how from based on the images, do you detect any sort of cancer predictions or any other like related to medical fields. So in each industry, it's important like to apply this. Then we have is more attention on explainability. Just give a quick glance on it. Like right now, your model is predicting, for example, it's a cat. So how do you know it's a correct prediction? So you need to go back and backtrace and make sure that your model is giving you correct predictions. For that, we have different metrics in machine learning, like true positive, false negative, false positive. So trying to understand these metrics and getting back to the model and making sure your model is giving you correct prediction. That's really important. Not just giving randomly some insights and then you say that, okay, this is the result. But before you confirm that, always go backtrace and make sure that your model is correctly predicting it by going through each step of your model and then trying to understand that. And next is advancements in training and optimization technique. That is, right now, as I said, deep learning has lots of data to deal with. So the training time could be very large. It may take many days as well to train your model. So how do you make it more efficient and use different optimization technique? This will be a little high level topic, like we have different optimization techniques in deep learning that is helping to make a model smaller. So that is currently what many researchers are working on. If you have a complex model, make it smaller. And so that you can reduce your training time. Instead of training it for many days, you can reduce it to at least 1 day. So that is helpful. So there's a few areas that currently many of them are working on. So to tell quickly about the careers, so I would say that we could divide it into two parts. Like if you're very good in programming, like, or if after 4 5 years you try both programming and statistical methods and everything, and you feel that you have a true genuine interest for programming field, and like by using like different programming languages like Python is obviously the best language to start with, as it's more simple. But later on we can even check programming languages like C++. So if you feel you have a genuine interest, like after, like since you're just in 10th or 8th, there's lots of time. So within 3 or 4 years, if you feel that you have very much passionate about it, then it's highly recommended that you go for job. You can get into jobs like machine learning engineering, as you can see in the table, or data scientist. So right now, the legend, I would say, the dark blue is like we have different skills on the left side, and the dark blue shows that it's very important to have those skills to get to the required jobs that you can see on top, like data analyst, machine learning engineer, etc. And the small circles that you can see in light blue is not that important. So the dark blue is the ones that is very must to have those skills, as you can see in the left side, to get the required job. So if you see the in the table for machine learning engineer and data scientist, you can see that it's very important to know about statistics, machine learning, obviously, and programming languages. So that's what you can see in in big circles of dark blue shaded colors. And on the other side, if you feel that you're more interested in like visualizing the data or doing a bit of more of mathematical side, like statistical approach, finding the mean variance from the data, or applying different tests that you have in statistics, like chi-square mean test and all that. And so that's when you can focus more on data jobs like data analyst or data engineer. So analyst and data engineers won't go much into machine learning or deep learning, but in fact, they will always try to understand more on the data. And like as I said, data analysts would mostly focus on how you can visually represent your data by using different tools. Like we have like I think we have BI, business intelligence tools, and other like Tableau is one way of representing your data. So data engineers basically they can use different tools instead of using directly programming languages like Python. You can use different tools to help you to get to do some inference or trying to understand some trends in the data. And also, I feel for data engineers, mathematical knowledge is quite important, like statistics, especially, is somewhat important. And also, trying to get great awareness about the data would be very much important in their case. So, to give a very generalized high level view, I could divide this into two parts. If you are very much interested in programming related topics, like after like I think if you've started right now or the next year, within the next 3 to 4 years, you'll be able to understand how passionate you are about it. So if you're into programming, the jobs would be into machine learning engineer or data scientist. So initially you will start with a very basic role. Either you'll be doing some internships and then you can get promoted up till to a senior data scientist, or a lead team leader, or like a team or a senior data scientist. But if you're more interested in using different tools for getting your inference of different models, or and also if you want to work more on the data side, that is trying to understand about what like missing data or noisy data that happens, how to tackle them, and then using different statistical approaches. So statistics is more on mathematical sides of mean variance and all those. That's when you can get jobs more related to data analyst or data engineer. And so that would help you to reduce less effort, to use less effort in programming, and more on using tools or different techniques for visualization of your data, trying to find different trends, etc. So I think you all have a lot of time to understand that and fit yourself in these two categories. That would be helpful for you. So just to make a differentiation, data science and data analytics skills you need. For data science, basically the skills you need is computer science, bit of machine learning, then software development, writing algorithms. So I think that all you'll do a bit later, maybe in your course, maybe in 11th and 12th, I think you may have a bit of it. And for data analytics, you don't need much of programming knowledge. You will basically use different softwares and tools. You will have different business intelligence tools like Power BI. And for data visualizing the different graphs that you draw, you can use different softwares like Tableau. So data analytics would require less programming, background, more using more of tools and softwares to get your work done. And data science would require more computer science background and more of machine learning algorithms, right? Understanding these models and deploying them and all that. So it's important to understand after maybe 4 or 5 years at least to get an understanding of how or which category you fall into. So it'd be easier to develop your skills and reach to a very high level role in the next 10 years or so. Yeah, so this is basically my slides. So right now, there's lots of research being done in deep learning for different fields and applications. And so right now, it's a very impressive field, like right now, how it's going and the applications it can be used for. Deep learning is highly recommended for those who are very interested to start. And also it's important to know about it to see whether you're passionate about it. And so I've seen many students that get into this programming and see how passionate they are. And if they are for example, for 2 years you work on it and you feel it's still very passionate, means you have something in it. And but if you have been working for it for the 4 years or so and you feel less passionate, it's obviously good to get deviated a bit and get roles into like data analytics and so on. So I think trying it out will help you to understand in which career path you want to go to. Yeah, so I think that's it for my slides part. So if you have questions.
Yeah, thank you so much, Sanju. That was really helpful.
Yeah.
If you'll have any questions, please ask, and she'll be very happy to answer them.
Yeah, sure.
Divina, you started with a couple of questions. I hope they are answered by now. Aditya, you have any questions? Anybody else? I guess, Sanju, nobody has any
Yes.
questions today.
Questions. Okay.
No, but
I just wanted to say hi. My name is Vedika.
Okay.
I was just before your session, I was really trying to see the differences between the data science and the analytics part, and I think you did a very comprehensive presentation on it. So thank you
Yeah.
for that.
Yeah,
That
it's
was
good.
great.
Yeah.
and
Yeah, as I said, like I've seen like many people, I think many people who are currently working in different industries, especially in mechanical or some other field, they're trying to move to, many of them are trying to move to data science and data analytics. So some of them are still a bit confused on what is data science and what is data analytics. So especially those who are working in other industries like mechanical and all that. So for them, whoever is not interested in much programming is obviously good to go into data analytics skills than data science. So data science would require you to be quite passionate in programming to continue it for a longer term. If your long-term goal is if you want to be a data scientist, then you should be like well versed. You should feel passionate about it at least in the first 4 or 5 years when you're learning it, and then to carry it on later on.
Right. Thank you.
also, Tanvi is asking if there are any particular data analytics courses that you would recommend.
I feel Udemy is good, but I will maybe have to check for data analytics. For data science, for sure, it's good, like for learning about neural networks and machine learning. For data analytics, I may have to search, but I know Udemy is a platform, and then we also have Coursera. These are the two sites that most most researchers go through the different courses in there. I think Udemy has more practical approaches. I mean, Coursera is good. I think these are both Coursera and Udemy.
Also,
And also, yeah, okay.
go
Yeah.
ahead.
And also, I think there are other for tutorials, Udemy and Coursera is good. Like if you want video lectures by different professors from different university, etc. But other than that, I think we have the W3 schools, or I'm not sure the correct name. So these are like online sites where you can read through the pages and see what they have done. Yeah.
Also, Sanju, another question. You know, in one of your slides, you had the intersection between data science and machine learning. So the question
Yeah.
is that overlap that was there, was
Mm.
it in terms of skills or particular roles?
Was it the
Yeah,
career
this one.
slide?
Yeah,
Okay,
this
one
one, this
second.
one. Yeah, you were right. The one with the Venn diagram.
Okay, Venn diagram one.
Yeah.
Yeah, this would be like skills. In terms of skills, like you would need a bit of computer science skills. You would need computer science skills and data science. So in terms of skills, that's why the intersection has come in. You may require different skills for making making insights or different predictions. But then you would also require statistical knowledge, more of statistical knowledge of using different like tests. I think in statistics they have like chi-square tests and different methods. So the bit of mathematical and statistical approach would be needed in extra of machine learning approaches or computer science. So the
So,
intersection is basically for you having computer science knowledge as well.
so may I
Yeah.
ask you a question, since the entire big circle, the blue circle is data science. So does
Yeah.
that mean that one can run, some sort of program on data science without
Yeah.
doing machine learning?
Yeah, they can do it. They can do it by using statistical or more of mathematical approaches.
Then,
Yeah.
but then doesn't that become data analytics?
In data analytics is basically for not predicting or finding like trends by deploying different models. But if you want to do some sort of visualization of your data, like using Tableau software, you want to find some trends in your data. So
Okay.
you're depending more on tools than using your programming language or programming knowledge.
Okay.
So yeah.
So data analytics doesn't do predictive work. It is more to find a pattern, whereas data science,
Yeah.
you're actually using that, to do some sort of a prediction of what might happen in the future.
Yeah. Yeah. Yes, that's correct.
And you're saying that one can do the prediction without running an ML model.
Yeah, without having using exactly a machine learning model, you can use different tests in statistics or mathematical approach, and then also run using that.
Yeah, that makes it a lot
So
clearer.
more of neural network architecture would be needed in machine learning and deep learning in deep learning techniques, but you do not use a neural architecture in data science, like neural architecture approach.
Okay.
Yeah.
Does anybody else have any questions? That was actually really helpful. Even I wasn't very clear between the difference between the two.
Yeah, because many are confused, but I would feel like it's more about like later stage, like once you finish your school, once the students finish the schooling and once they get into the program, I always feel it's important to understand at least after a certain specific amount of years that you maybe use, like for most of the students may go into taking a bachelor's in computer science. So at the end of your bachelor's, you may mostly get an understanding of what you're really passionate, and then it's important to choose the right career so that you don't fall into something that you don't want to do the rest part of your life.
Okay.
Yeah.
Thank you so much.
Yeah.
If nobody has any more questions, we should, thank Sanju and let her go, because it is, I think, 11:30 in the night for her.
Yeah. It's 11:30 now.
Yeah. So thank you so much, Sanju. That was really helpful, and we'll be in touch.
Yeah,
Bye.
sure. And thank you, Supriya, for inviting me. And I think it's been so long that I've been having the audience as students from school, and I've been just giving presentations for other audiences of my university, but not for like students in school. So it was a different experience. Yeah, thank you. Yeah,
Bye-bye.
thank you. Bye.